Previously, I discussed regarding to the series connection of resistors. Over the series connection of resistance, effective resistance is a sum of all resistors or addition of given resistors is nothing but effective resistance. Now in this video, we will discuss regarding to the if the resistors are connected in a parallel connection, then what is the effective resistance. So series connection means dissimilar terminals are connected. Over the parallel connection means all similar terminals are connected. Then we will call it as a parallel connection of resistance. Over the series connection of resistance, we saw that current flowing in all resistors is same, but the voltage drop across each resistor is different. So in the parallel connection, what is the current flowing and what is the voltage drop across each resistor, we will see that is. So now see the circuit diagram for the parallel connection of resistors. If there is two or more resistors, the similar terminals are connected at one point, then what is the effective resistance? So let us say these all are connected at one junction. Let us say this point is a junction of the all resistors. So this is the point P, let us say, and this is the point Q. This is the first terminal, this is second terminal, first, second, and another second terminal. All first terminals are connected at one point, all second terminals are connected at one point. Then such a connection we will call as the parallel connection of resistance. So let us say there is a battery of V volt is connected to this circuit. To make on and off the circuit, we connect a switch. To measure the current flowing across this whole circuit, we measure a current measuring device is called ammeter. Say here when switch is closed, the current I is flows, and at the junction P, there is three paths are there for the current. As three paths are there, in each path depends upon the resistance R1 and R2 and R3 capability or capacity, the current is flows in the three resistors like I1, I2 and I3. Here it is I1 current, here I2 current and I3 current will flow. As there is a current is flowing, so we will make a small modification in the circuit. We measure the current here in the R1 resistor, in R2 resistor and R3 resistor, because current is different. But whereas in series connection, current in all resistors are same, voltage is different. Then we connected over the voltmeter. So here we connect A1 ammeter, A2 ammeter and A3 ammeter. Again these three currents I1 and I2 and I3 all together comes added at Q, and I current is flows like in a series connection of these components. So current is outside is I. In the circuit, depending upon the resistance capacity, they are I1 and I2 and I3 current is flowing. So in this particular case, these all resistors, effective resistance, say as it is a R effective. This is equivalent circuit. Equivalent circuit for the above parallel connection. So here there is a battery and a switch and ammeter is connected. This ammeter measures the circuit current. So this is a effective resistance in parallel connection. So I current is flowing across this. So we can say here I current is divided into three parts. They are I1 and I2 and I3. Then we can say here in parallel connection, voltage is same, but current is dividing depending upon the rating or capacity of resistance. So in parallel connection, voltage that is we can say potential difference across each resistor is same, but current is different in each resistor. Means current is different. How current is different? I current is sum of I1 plus I2 plus I3. This I is divided into three parts, that is equal to I. According to Ohm's law, current flowing across the R1 resistance is current in R1 is already we know current I1 is equals to voltage by resistance R1. Similarly, current in R2 is I2 is equals to V by R2. Similarly, current in R3 is I3 is equals to V by R3, and we can say total current I is equals to, that is total current I, current in R effective is I is equals to V upon R effective. So this is nothing but current flowing across the I1, I2 means R1, R2 and R3. At the same time, the current flowing in the effective resistance is nothing but V upon R effective. Let us substitute these three currents in the above equation and try to find the effective resistance of the total circuit. So let us see that. So substitute in the above equation, that is I is equals to I1 plus I2 plus I3, which is I is nothing but V by R effective, that is V upon R effective, is equals to I1 stands for V by R1, and I2 stands for V by R2 plus I3 stands for V by R3. So potential is same on LHS and RHS side of the equation. Let us take a common, that is V 1 by R1 plus 1 by R2 plus 1 by R3. So here this is V R effective, V by R effective. V is cancelled one times. Then we got R effective is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is nothing but effective resistance when the three resistors are connected in a parallel connection. Means when the resistors are connected in parallel, the effective resistance is sum of the reciprocal of resistors is nothing but reciprocal of the effective resistance, or reciprocal of effective resistance is equal to sum of the reciprocal of each resistance is nothing but effective resistance in a parallel connection. Okay, in series connection just addition of each resistance, but in parallel connection it is the reciprocal of addition of all the resistance. So this is how we calculate the effective resistance in parallel connection if there is three resistors are connected. Let us try to write some formulas over if the not only three resistors, more than three resistors or less than three resistors, like two resistors are connected in parallel. So what is the effective resistance? Let us go with the formulas. If there is two resistors are connected in parallel, two resistors R1 and R2 are connected in a parallel. whenever you will see there is a two resistors are connected in a parallel, R1 and R2, then effective resistance R effective is sum of the resistance R effective is equals to 1 by R1 plus 1 by R2, sum of the reciprocal of each resistors. But we know that we can solve this somewhat and we can make a conclude one formula. Again need not to do the same kind of calculation. So LHS side we can take LCM, that is R1 into R2. R1 in this product how many times means R2 times, R2 how many times means R1 times. So we can write R effective is equals to this. So we don't want R effective value, always we can calculate the R effective, not reciprocal of R effective. Make a reciprocal of LHS and RHS, then we can say R effective is equals to R1 plus R1 R2 by R1 plus R2. This is nothing but effective resistance in a parallel connection when there is a two resistors are connected in a parallel. See how to identify whether they are parallel or not. We have to see that a current is flowing, this current is getting divided at this junction. As current is dividing, then we have to say that it is a parallel connection. In previous video I told you that if current is same, then it is nothing but a series connection. Here current is getting dividing, then we have to say it is a parallel connection of a resistor. If n resistors are connected in parallel, if n resistors of R1, R2, and so on, Rn resistors are connected in a parallel or connected in a parallel, then effective resistance is R effective is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on n times 1 by Rn we can write. So this is nothing but effective resistance of different are connected in a parallel. So in the same question, n resistors if n resistors of R1 is equals to R2 is equals to R3 is equals to and so on n times or n resistors are connected Rn, all are equal, then effective resistance is directly I am writing R effective is equals to R by n. Effective resistance is R by n. In parallel connection, you have to identify clearly. I will write here, see R effective is nothing but R by n. Over series we saw clearly it is nothing but n into R, here R by n. So you have to remember this one. Okay, next one more formula we can say a wire of R ohms is cut into n parts and connected in terms of parallel, then effective resistance is C. A wire of R ohms is cut into n parts and connected in a parallel connection, then R effective is nothing but R upon n square. This is a special case we have to remember. So these are the formulas which are present in the parallel connection of resistors. Okay, whenever you will get any sort of problem on parallel connection, we can use these formulas and you can resolve the answer for the given particular question. So writing note these all points and try to remember. We have to remember must these points. So similar formulas are given in the series connection also. Note down those formulas and read properly for exam. Thank you.